I'd like to do is first get questions, a list of questions, so that way, Sherry, you could get the list of questions so people know what is going to be covered in this set, or the problem, or the solution section. And then once I'm done, we'll stop and then we'll finish the next lecture, or the next section. So, are there any questions out of 12.1?
12.1, I have 45.
45?
Yes.
Anything else?
11?
11?
Yeah.
All right. Any others? Okay, let me take a look at them first before. Sometimes in the summer with things being so quick, there'll be a few that I decide to skip. But let's see, plan a little bit, that's good. And then go to 11.
Yeah, the one about the camera ratio,
Okay.
and how to get the camera ratio reading.
Say that one more time.
And how can we recognize the camera ratio? Like,
Oh, okay. So, yeah. All right. So we'll go through this. Okay. Are you recording? Oh. Okay. So, we'll just cover these two problems out of 12.1, or so number 11. So it says, give an example of the formula for the nth term a sub n of a sequence satisfying the given condition. If it's impossible to fulfill all the conditions, then so indicate. So, we want to find an a sub n where the ratio of consecutive terms is 1/2. Right. Yeah. Consecutive terms is 1/2. Okay. So what does that mean? What are the consecutive terms? So you got a sequence, A1, A2, A3, and so on, right? And we want to find a formula for a sub n. So what is, well, a sub 2 and a sub 3, those are consecutive terms, right? So you got one term and then the next, and then a sub 4 will be the consecutive term there. And so we want to find, we need to find a sub n such that the ratio, so that's the quotient, right, of consecutive terms. So a sub n plus 1 over a sub n equals 1/2. Does that make sense? And all you're supposed to find is one example. If you can find one, there's a bunch, you could come up with a bunch of different examples. But essentially what should be true, right, is we come up with this. A sub n plus 1 is then 1/2 a sub n, right? So here, this starts to look like a recursive definition, right? You see the future, or the n plus 1 term if you know this. But again, recursive definitions need a starting point, and so you just have to start somewhere. So we'll just say, we'll start at a sub 1, and we'll just say it's 1. Does that make sense? And then that formula would give you that sequence. So, and really all you need is anything where this happens would be true. And so let's look at this sequence first. So a sub 1 is 1. What's a sub 2? 1/2. What's a sub 3? 1/4. And so that sequence actually looks like this sequence, which is just powers of 1/2, right? So 1/2 to the n, where n starts at 0. So there would be one solution. Does that make sense? And whatever you picked as a different value up here, you'd get a different solution. I think that would do it. Okay? All right. And then the other one was 45. So this one just asks you to find the limit of the given sequence. And so, write it up here. Okay, 2/3 to the n. And so, let me just write it like this. So we're looking for the limit as n goes to infinity. This really comes back to something we had talked about back in Calc 1, but maybe we've glossed over a little bit. There's really no work to be shown here. What's the answer?
0.
0. Why is that?
Because it's less
Raised to
than
infinity, 0.
Well, so it's a number less than 1
Yeah.
raised to infinity, right? And so if the number's bigger than 1, then it's infinity or doesn't exist. But if it's less than 1 in absolute value, you just know it's 0. So that's all you have to do. Does that make sense?
I just want to ask about the steps.
Yeah, there's not really any work to show in this case.
Okay.
It's kind of, the same thing like these, right? The limit as n goes to infinity of 1 over n to the 5th, we just say it's 0, right? You got 1, you divide by a big number. Here you just think small number raised to bigger and bigger powers goes to 0. And when I say small, I mean less than 1. Is that good?
Yeah.
Okay. Any other questions then out of 12.1? Yeah.
Could we go over 55?
Sure. All right, so 55. So same kind of idea, right? And this is, you're going to see a ton of stuff like this in a few minutes. I guess in a few sections. All right. That's a terrible looking bracket. Okay, so this looks like a giant mess, right? I mean, on the surface, you're like, ooh, that's pretty ugly. But we're asked to find the limit of this, so the limit as n goes to infinity. Let me just write it out. To the n plus 1, or n plus 1 factorial, and then that whole thing, I'm just making this fraction extra large so we are clear, right? It's this fraction divided by that fraction, is that okay?
Yeah.
So, let's just do some algebra. So dividing by a fraction is the same as multiplying by, it's
1 over.
1 over or it's reciprocal, right? You can just flip it over. So this will be the same, right? No limits being taken. I'll just rewrite this. And then flip this over. So times n factorial over 2 to the n. All right, so now we want to start canceling some things. So what's 2 to the n plus 1 divided by 2 to the n is just the 2, right? Does that make sense? So you should get the limit as n goes to infinity of just 2 up top. And then what about the n plus 1 factorial and the n factorial?
N plus 1.
Yeah, it'll just be n plus 1. Let me just write it out to the side here. N plus 1 factorial is what? N plus 1 times n and everything smaller, but that's n plus 1 times n factorial. Does that make sense?
Okay.
And so I'll just write it out. No, but you simplify it down to like this, and then the n factorials cancel. And now you just have 2 over n plus 1, and what does that go to?
0?
0, right? 2 divided by something bigger and bigger.
Okay.
Does that make sense?
Yeah.
And we'll see this a bunch with factorials. It's important to sort of understand why those factorials cancel. Keep encountering them as good examples when we get to the ratio test on these. All right, any other questions? All right.